Hello and welcome back to the Hibernate course. Chapter 8, we're now going to introduce relationships to our design. One of the big differences between relational and object is relationships. In Java, relationships are modelled using references between objects, but in relational, foreign keys are used. Now, one way isn't better than the other, it's just different ways of expressing the same thing. But ideally, it would be good if we could work with relationships in our Java as usual and let Hibernate deal with foreign keys for us. That will make our Java feel more like, well, Java. A single annotation is all we're going to need in this chapter, and it is called many-to-one. We'll also see how to update relationships, which again should feel like natural Java. So we've now got to the point where we can create objects in memory, and without too much hassle, we can store the object in the database. And we've seen that Hibernate deals with the details of creating and executing the SQL statement. Now, of course, on a real system, we're going to need to be able to work with more than one class. And naturally, the classes that we work with are going to be related via regular Java relationships. I've said quite a lot already about the mismatches between the object world and the relational world. And here's another big mismatch. Relationships are handled very differently in those two worlds. You know about Java relationships. We can have one object holding a reference to another object. Whereas in the relational world, relationships are handled via foreign keys, a very different concept. We're going to want Hibernate to help us with that mismatch. And our general aim in this chapter is that we're going to relate objects together in the usual Java way. But Hibernate is going to make sure that the foreign keys are correctly set up in the background. Now I'm going to expand our example that we've been working on throughout this course. You're familiar now with the student class, and we have the data in there of an enrollment ID, a student name, and so on. We also had an attribute holding the tutor's name. Now that clearly was just some kind of a placeholder because tutor is definitely going to be a class in its own right because we need to be able to manage the details of tutors as well as students. We'll code up the tutor class in just a few moments, but I can imagine that we're going to have in there details such as the tutor's name, maybe their salary, and anything else that we want to manage. Now, the relationship I'm interested in for this chapter is that each student is going to be allocated a single tutor, and this relationship is going to be the supervision relationship. By that, I mean that each student is given a supervising tutor, just one of them, and this tutor will be responsible for the student's progress through their studies. Now, of course, a student will be taught by multiple tutors, and we're going to look at how to handle multiples in a very short while. But to get us started, I want to focus on this many-to-one relationship. By many-to-one, I mean that we can have many students supervised by the same tutor. How do we handle this in Java? Well, I'm hoping that you're going to find that a very easy question to answer. We're just going to need an attribute in the student class, which is going to hold a reference to the supervising tutor. And then we will need Java methods to allow us to set that relationship up. As I say, I'm assuming that's fairly easy Java for you, but let's get into Eclipse, we'll get that coded up, and then we'll have a look at how to get Hibernate working with the relationship. So if we start by looking at our student class from the previous chapter, you'll recall that we have an enrollment ID, a name, And there's our tutor name. Now, as my comment implies here, we need to make this into a reference to a class instead. So let's start on that, and we'll just do this quite quickly. I'm sure you're okay with the details of this. We'll create a new class called tutor. We'll leave it in the domain package, and we don't need to generate anything. And we'll start with, we're going to have a string, which is going to be their staff ID. And we'll have a look later at the details of how we're going to generate that staff ID. We're going to need a name for the tutor. And I think we're going to store the salary of this tutor as well. And just to keep things simple for now, we'll make this an integer. And we're going to look later at how we can deal with different data types in here. Now, we are going to be making this a persistent class. We're clearly going to want to save instances of tutor. So you'll be familiar with what to do. We effectively have 3 separate steps. We have to add the entity annotation to the top using the Java persistence annotation. We're going to need an ID annotation. I spoke in a previous chapter about how it's usually recommended to create a business neutral key. We could use staff ID and it will certainly work, but it's usually safer if we create a new field. We're going to make it an int and call it ID, and we're going to use that field purely for the purposes of the database. We need to annotate that with the @ID annotation, once again from the persistence package. And once again, I want to generate the values for this field. So we will use generated value, and we need strategy is generation type dot auto. Control Shift and O, and we'll check the imports. Okay, and remember there's a third step, which is we always need for Hibernate, and I'll just comment this required by Hibernate. We're going to have a constructor for tutor that takes no parameters, although we don't have to do anything inside that constructor. So that's the 3 rules for Hibernate, but I'm going to include a proper constructor as well, a real business constructor, as I'm going to call it. Business constructor, and well, I can actually generate this using the source option in Eclipse. Generate constructor using fields. Now I've got to have a think here. We're not going to be dealing with IDs, that's the database's job, but we are going to set the staff ID, the name, and the salary. So I'll leave those 3 fields checked. And that looks like a good constructor. I need to move my comment to be in the right place. So it's a very simple class to start with, but of course we can expand this out over time. But the purpose of this chapter is to look at how to relate students and tutors together. Let's go into our student class, and all I'm going to do is change the type of this attribute to be a tutor, and we'll need a better name here. I think we're going to call this supervisor, and the comment is now redundant. So I'm sure you knew that already, but the key thing here is that in Java, a relationship is managed by simply using the class name as effectively a data type. Now I'm just going to scroll down because some of my code is going to be broken now. It's going to be the constructors, and we don't have to make a big change here. This initializes a student with a particular tutor. So all we will do is we'll change the string into a tutor type. Just for readability, we'll rename this to be supervisor as well. And then we just make the change here as well. The supervisor is going to be set to whatever supervisor has been specified by the caller. This second constructor Well, this is where we have a student with no preset tutor, so we can go ahead and set the supervisor to be null. And I'm guessing that we've probably got a setter. Yes, we have a setter down here. I suspect that's a redundant method from earlier on when we were experimenting. I'll just check that. I can right-click on the method name here and go for references and projects. And that will give me a list of all references to that method in the project. And you can see there are no references. So I think I'm inclined to remove that method completely because it's clearly not in use anymore. I think while I'm at it, I'm going to go ahead as well and remove the number of courses setting there. And a little higher up, I think I'm going to take out number of courses altogether. We were just using that as an example field to allow us to change the column names and so on. So I don't think we really need that anymore. And I think I'm also going to remove the average score across all exams. I introduced that in the previous chapter just to explain the transient annotation, but we won't be needing it for the rest of the course, so I'll remove it. Of course, you can leave it in if you want to do something with it. So we now have a student's class with a relationship to a tutor. Let's go across to our test harness and let's do something with this relationship. Just to keep things simple for the next few minutes, I'm going to take all of the lines of code that are dealing with Hibernate and I'm going to comment them out. So Control// in Eclipse will comment out a block of code, and I don't need the session.save either. In just a few moments' time, we'll reinstate the commented lines once we've got the Java straight. So in the previous chapter, I created a new student and I used the version of the constructor that had just the student name. This time around, I want to create a new tutor and a student, and then I'm going to make the student be supervised by that tutor. And I'm hoping that this is very straightforward Java for you, almost patronizing Java really. Here's a new tutor, and we would just use the constructor for that tutor. We'll invent a staff ID, ABC123. The name of the tutor is going to be Dave Blofeld, and the salary is going to be, let's say, 30,000. I don't know what units they're in or what currency, and I don't really know what tutors earn. Of course, I will need to import our tutor, so I Control-Shift and O to get the tutor in there. And I've realised that at the moment, the only way I can relate a tutor and a student together is by using the constructor for the student. I think it would actually be more useful if I could say my student dot, and I can call the method anything I like. I know it's kind of conventional in Java to have a method like set tutor, and I would pass the new tutor in, but I really want to emphasize on this course that you don't have to use getters and setters all the time. So feel free to call this method getStudent if you want to, but I'm going to call it allocate supervisor. And I'm doing that to try to emphasize that there could be business logic involved in allocating the supervisor. Now, of course, we don't have that method yet, so we'll go into the student class. I'm going to put the method about here where the business methods are. So this will be a public void, allocate supervisor, and we'll take in the tutor, new supervisor. And for this course, we're going to keep it very simple. We'll just say that this supervisor is going to be the new supervisor. But once again, at the risk of boring you, I'm going to point out that we could have had any complex business logic that we like inside there. So let's run back to our test harness, and I suppose we ought to do something now. Let's just confirm that this has worked correctly by print out the supervisor for this tutor, and we will do system.out.println my student. We'll do a get supervisor name. Again, this is just regular Java, so it's up to you what you do here. You could have got the whole tutor object back, and then you could have called to string on the tutor. I'm just going to get the supervisor name for this student. So I will need to implement that method, public string get supervisor name, and we will return this supervisor's. I will need a getName method in the tutor class. So let's add that in, public string getName, and we will return this .name. So I'm being careful here to introduce the methods one by one as I need them. And I'm not necessarily just going to blindly generate all of the get and set methods. Anyway, I think we're now ready to do a run. Remember, I've commented out all of the database operations, so this should all be just happening in memory. We'll give that a run. And there we are. That's definitely running okay. However, now to get to the point. What I want to be able to do is to save this student and the tutor in the database, but I also want to preserve the relationship between the two. So we need now to reintroduce the database. So let's get these lines of code uncommented. I think I've lost my imports because of the commenting out. So I'll just reinstate the imports. And remember that the transaction class is the org.hibernate transaction. And I'll be explaining in a later chapter why there were two of them. But for now, I'm going to run this, but I want to have a little think about what's going to happen. First of all, if we go into our tutor class, I think we know what's going to happen here. Hibernate will generate a table called tutor. It will assume that because I'm not overriding any of the defaults with any annotations, that we need a column called ID. We need a staff ID, which will be some kind of varchar. We'll have a name and a salary column. And all of that will be generated, and we will automatically get an insert for our new tutor. Oh, having said that, however, what I've forgotten to do is I've forgotten to do the session.save on this new tutor. So make sure you've done that. Remember that all objects that are new to Hibernate, we have to call save on them so that we will get an insert into the database. But the big change in this chapter has been in the student class. Let's go back up. Now the same will apply. Hibernate is going to assume that we want a table for this student. Well, in the previous chapter, I overrode the default table name using the annotation here. For now on, we can remove that annotation and we'll go with the default table name of student. We'll get a column for the ID, a column for enrollment ID, even though we're not using it just yet, a column for the name. But what about the tutor? This is the interesting one. I think rather than coming up with some theory, let's just run the code and see what happens. You've probably had a break since the last chapter, so don't forget you will need to start your database or nothing useful is going to happen. And I'm also going to go into my Derby bin directory and run the ij command so that I can connect to my Derby database. Do you know, I can never remember the URL for the Derby database, but of course we can go into our project and look in the Hibernate config file, and there is the URL. In fact, I think I'll copy that, and then if you're running on Windows, you can click on the icon here and select Edit and Paste. It's a little bit clunky, that. Don't forget the semicolon on the end of the line. And then we can do show tables. Now, in the previous chapter, we were doing various experiments and we had the TBL student table there. I suggest that we drop that table so that we get rid of any debris from the previous chapter. Now, let's get into Eclipse and we're going to very tentatively give this code a run. We don't know if it's going to work or not. And yes, well, I think we can very safely say that didn't work. Plenty of red text there. And what it's saying is, cannot determine the type for tutor. And what it's effectively saying is, hey, this is a complex class. It's not a string, it's not a primitive, and therefore there is no obvious mapping for Hibernate to work with. How does it convert a tutor into a column? We are going to need an annotation here. It's a very simple annotation, but we're going to add it. Let's go into our student class. Here's where I declared the tutor property. I'm going to add in the annotation at many to one. And this tells Hibernate how to deal with this property. It's telling Hibernate that this is a many to one relationship. There are many students who can share a supervisor, but we in the student class only have a reference to one tutor. As always, that will need to be imported, and if we just check the import, you'll see, like all of the other annotations, they're coming from the Java persistence package. We don't have to do anything more than that. This immediately tells Hibernate that we want to relate to this tutor via a foreign key, which is, of course, the natural way of working with relationships in a database. And the really powerful thing about Hibernate is that's all that is needed here. If I give this a save and we go to our test harness, and we'll give this a run. Oh, it does look like we have another exception here. Let's have a look here. Exception in main, the annotation, many to one. Oh yes, references an unknown entity. I always forget to do this. Remember in the Hibernate CFG XML file, we had a line here which was pointing to the student class. And in basic Hibernate, we do have to list all of the classes that we want Hibernate to work with. You'll see later on in the course that there's a way of avoiding this, but for now we are going to have to manually input virtual pair programmers.domain.tutor. So that's another necessary step. Let's try again. And this time it looks as though something has happened. Let's get the console maximized. And of course we've got the show SQL set up. So our Java here has got a little bit obscured, but we expected to see the tutor's name output anyway. You can see that we have a fair bit of SQL going on here. In fact, it's 2 inserts and an update. Now, hopefully it's obvious what the 2 inserts are, one for the tutor and one for the students. We'll need to have a little look at what's happening with the update statement in a short while. What I'm more interested in is what's happened to our database. So let's do a show tables. And I hope you can see there that we now have a tutor table as well as a student table. So I'm going to do a describe on the tutor table. I think we used that in an earlier chapter. That will show us the setup of the table. So as expected, or I hope you've expected, we have an ID, a name, a salary, and a staff ID. But if we describe the student table, we have a big change. We have the ID, we have an enrollment ID, we have a name, but we also have here a foreign key pointing to the supervisor for this particular student. Now, we didn't specify this column name, supervisor_ID, So where did it get that from? Let's switch across to our student class. Now what Hibernate will do when it sees this annotation is it knows it needs to work with a foreign key called, and the default is, whatever the name of this property is, followed by _ID. I'll need to make a really important point. Remember in the previous chapter we talked about how you can put annotations on the fields, as I'm doing here, or you can put them on get set method pairs. If you've gone for the get set method pair approach, then you would need to have a get supervisor and set supervisor method, and you would put the many to one on the get supervisor. Remember that within a class, you have to be consistent. The annotations must be all on the fields or all on the get methods. If we want to override that default, then there's another annotation called @join column, and we specify the name of the column that we want. You might prefer to call it, say, tutor _FK, which is quite a common convention to remind you that it's a foreign key. As always, that will need to be imported, and once again, that's from the persistence package. I'll go to my database and I'll drop the tutor table. Oh, actually, I can't drop the tutor table because there is a foreign key. There is a relationship between students and tutors. So, in fact, we need to drop the student table first, and then we can drop the tutor table. So I'm going to run the code again. And if I once again describe the tutor table, we can see the fields as before. It's actually the student table that's of interest. And I hope you can see now that the foreign key has now changed to tutor _FK. But of course, the interesting thing is, what are we now seeing in the student table? So I'll select all the columns from the student table. And as always, the output here is not terribly readable. So I think actually I will select the name and the tutor foreign key from the student table. And there we can very clearly see now that Kathleen Heddle has a relationship to the tutor of ID 1. Now this has to be one of the most powerful features in the whole of Hibernate. By adding a very simple annotation to one property in our student class, we can now see that Hibernate is pretty much effortlessly handling the relationship between the two classes. I need to mention though that if we look at the SQL, so we saw before that we have an insert to insert the student, and then an insert to insert the tutor, but it has to do a further update to change the foreign key for that particular student. Now you might be confused about why that's happening, because if you think about it, it could have included that foreign key in the original insert statement when it inserted the student. And you'll find that Hibernate will always do that, even though it looks a little inefficient. And it's because in non-trivial use cases, it might not be possible for Hibernate to set up the foreign key immediately. And in fact, thinking about it, if we switch across to our test harness, we happen to do the save down here towards the end of the use case. But we could have done the saves a little higher up, i.e. immediately after we'd created the students and the tutor. Now, at this point in the code, those two objects are not related together. We only relate them together here. And if you remember from our earlier discussion, quite a long time ago now, the save method, if we're generating IDs, save will immediately issue an insert. So we're effectively seeing one insert here, and then we're changing the objects. And remember from before, we will have a dirty check here on the commit, and that is where we're seeing the update being issued. So although it might look a little inefficient, I think really in practice it doesn't make any difference at all to performance. Hibernate will always do relationships as a separate update, really just to make sure that it doesn't get into a mess with any kind of ordering or any kind of constraint problems. So we can now relate two objects together, and as long as we've saved both of those objects, then the foreign keys will be handled automatically by Hibernate. Just so that we've got some useful data in the database, I'm going to run this code again, but I'm going to create a new student with a different name. I think I promised to use Olympic athletes in this course, but it's taken so long to record. The Olympics are now a distant memory, but I think I'll go with Alicia Coots. I think is Australian. And for the tutor, we'll use the name of Michael Young. And I suppose we ought to do a different salary. Oh, and we definitely want a different DEF 456. We'll just run that through, and unless something's gone badly wrong, that should be okay. Yeah, and I'll just check that in the database. I'll just repeat that query. So Kathleen Heddle has tutor 1, Alicia Coots has tutor 2, and we'll select the names from, in fact, we'll select the ID and the name from tutor. And so we can see the relationship there. Kathleen Heddle is supervised by Dave Blofeld, and Alicia Coots is supervised by Michael Young. So what am I going to do with that data? Well, of course, as well as inserting into the database, we can also do queries. Now we've got two very big chapters coming up later on the course on how to do querying. It can get very sophisticated indeed. But you already know about the method called get, which effectively finds an object from the database. So what I'm going to do is I think I'm just going to comment out all of this code here. I don't normally like commenting out code, but I want to leave it in place so it's there for the sample solutions. And this time I'm going to work with the existing data. I'm going to find the student with ID 1. So students found student equals session dot get, and if you remember from previously, we specify the class on which we're searching for, followed by the ID of the object that we're looking for. And I'll always forget this, we do need to do a cast to turn the object back into the correct type. Okay, so as we did previously, no big surprises here. We can print out the found student. I think we have a good toString in there, so let's give that a run. And that's good. There's Kathleen Heddle appearing on the screen. Well, that's nothing different to what we did in the previous chapter. But the important thing here is that we don't have to do any kind of complex joins or anything like that in order to be able to work with the tutor. I can perfectly well do system.out.println, and I think we had a method in there called getSupervisorName, and if we run again, there's our student name, and it's happily finding the name of the supervising tutor. And we can go a little further than that. We could say tutor supervisor is equal to the found student dot, and we can get the whole supervisor via getSupervisor. Now, I'm going to have an error here, but that's only because I haven't implemented that method yet. And I think I'm going to be lazy now, and I'm going to use the quick fix here. I can click on Create Method getSupervisor in Students, and it pretty much automatically builds most of the method. If I remove the comments, I can then do return this dot supervisor, and that will return the whole object back to our client. Just have one too many round brackets there. And then I could go off and do things with the supervisor. Now I don't have any interesting methods in here yet, but I know I can do supervisor.getName. But really importantly, if there were interesting business methods in there, I could now go and call them. Let's do a run here. And there is the tutor appearing correctly. Now I've been deliberately kind of hiding the SQL, but I think we ought to have a little peek at what's going on in the SQL. We're going to talk in great detail about these queries later on and how we can tweak and tune this for performance. I want to mention right now that in fact we only have one select statement with a left outer join. Now I'm assuming you're okay with left outer joins, and remember there is a short session on an SQL refresher as part of this course, but suffice to say for here that that means that as well as loading the student object, it's also loading the tutor object. So here in our Java code, we don't have to do anything with the foreign key. We don't have to go and do another query. We don't have to get the key of the tutor and then do another get. Oftentimes in Hibernate, it's enough just to get a single object, and then we can use regular Java relationships. I'm going to clean this code down a little bit, return it back just to finding our students. And I want now to look at how do we modify a relationship? Well, really, you know the answer to that. It's exactly the same as modifying any other data in an object. Once we've done either a save, or in our case, a get, this object called foundStudent is now persistent, meaning that any changes we make to it will be dirty checked at the commit point. So that means that we can very simply do something like foundStudent.allocateSupervisor, and we can allocate the student to another supervisor. Now this supervisor can either be one that we found from the database, or it can be a brand new one that we've just saved in the database. Let's say that we want to, I'll just pull up the database again. Now, remember at the moment that our student ID 1, that's Kathleen Heddle, is associated with tutor ID 1, and student 2 is associated with tutor 2. But let's say I want to move Kathleen Heddle to also be in Michael Young's supervision group. So effectively I want to change this foreign key here to be 2. How do I do that? Well, I need to do a find. So I will say our new supervisor, and it's not really a new supervisor, but it is a new supervisor for student ID 1. We'll do the same process. We'll do a session.get tutor.class, but we're looking this time for tutor ID 2, and then we can allocate that supervisor to student ID 1. In other words, all I'm doing here is modifying the relationships in Java memory. And what we expect to see is on the commit, the Java relationships will then be reflected in the database. Let's see if that works. We'll give this a run. I certainly saw a lot of SQL flashing past. Let's have a look in the database. We'll select the, well, we just need to select the student rows. And there we are. Now, Kathleen Heddle is associated with tutor 2, that's Michael Young, and so is Alicia Coots. Once again, and I think I'm going to say this a lot of times on the course, here in the Java, we're dealing with natural Java relationships, and we let Hibernate deal with managing the foreign keys behind the scenes. If we wanted this student to no longer have a supervisor, then we can remove that line where we're finding the supervisor, and we can allocate the supervisor as null. And if we run that through, and repeat the query, Hibernate's now clever enough to set the foreign key for that student to be null. So we're now started with relationships. There is still more to do, but it's time for a break. Now, a big problem when working with a database in Java is that relationships work differently in the object world and in the Java world. It's foreign keys on the database, and in Java, it's references. Now, Hibernate lets us change the Java references, and the work of updating the foreign keys is then done for us. Now, I must stress there's nothing wrong or difficult about foreign keys, but they don't feel natural in the Java code. So we only needed a single annotation at many to one, because we're working with a simple relationship where we can have many students supervised by a single tutor. In later chapters, we'll look at more complex relationships. Updating the relationships was easy. We just changed the references in memory, and when you reach the commits, you'll get a dirty check, which also handles changing foreign keys. So coming next is how to handle collections, or in database terminology, one-to-many relationships. It's not much harder than what we've just done, so I'll see you in chapter 9.